Hi guys, welcome back to my YouTube channel. So in this video, I'm going to explain the Floyd Marshall algorithm, which is used to find the shortest path between all the pairs of vertices in a weighted graph. So this algorithm is especially useful when we want to know the minimum distance between every node to every other nodes, not just from a single source. So it works for graphs with both positive and negative edge weights. Unlike other algorithms, Floyd Marshall finds the shortest path between every possible pair of nodes. So the Floyd Marshall algorithm uses an adjacency matrix to represent the graph. So each cell in the matrix represents the distance from one vertex to another. The algorithm works by considering each vertex as an intermediate point between every pair of vertices. So for every pair of vertices I and j, the algorithm checks whether going through an intermediate vertex k produces short path. So if the distance from I to j is greater than the distance from I to k plus k to j, then we update the distance. So this process is repeated for all vertices, resulting in the shortest path between every pair. Okay, so right now we're gonna find out the shortest path of each pair of vertices of these weighted graph. So for that, we're gonna draw the distance matrix. So for that, we have to follow some certain rules. All the diagonal elements would be marked as 0 because we don't have any edge. Like in this case, 1 to 1, 2 to 2, 3 to 3, 4 to 4. So therefore, we're going to mark these as zeros. So the all the diagonal elements would be marked as 0. And also if there's no any direct edge between pair of vertices, then it is counted as infinity. So in this case, like from between these nodes 1 to 4, there's no any direct edge. Therefore, we're gonna count this distance as infinity. So right now we're gonna fill this up. So so as I said, all the diagonals would be marked as 0, and then we have to fill these blanks. So what is the distance from 1 to 2? So you can see here's the way from this node to this node, it is 9. So we're going to mark this as 9, and then 1 to 3. So you can see this is the distance from this node to this node, which is minus 4, and 1 to 4. So in this case, we don't have direct edge, so therefore we are going to mark this as infinity. And this row from 2 to 1, it is 6, you can see, and then 2 to 3, and right here there's no any direct edge for the 2 to 3. Therefore we are gonna mark it as infinity. And 2 to 4, and 2 to 4, it is 2, and then 3 to 1, and you can see there's no any direct way, so therefore we're gonna mark it as infinity. And then 3 to 2, okay, so you can see 3 to 2 is 5, and then 3 to 4 is and also right here we don't have any direct edge, therefore we are gonna mark it as infinity. So 4 to 1, there's no any direct edge, therefore we are going to mark it as infinity. And 4 to 2, there's no any direct edge, therefore we are going to mark it as infinity. And then 4 to 3, 4 to 3 is 1. So this is the distance matrix, and also this is the initial matrix. As I said previously, we are going to use these elements as middle vertex to find out the uh, shortest path of each pair of vertex. So we are going to do the D1. So right now we are going to do the D1. For that we have to consider the element 1 as the middle vertex. So we are going to find out the shortest path between each pairs via 1, because we are finding the D1. Therefore, we have to consider the D1 as our middle vertex. So from that, we are gonna implement the D1. So for that, we have to consider the D0 matrix as our base matrix. So from that, we are gonna draw the D1 zeros, because 1 to 1, 2 to 2, there's no any edge. Therefore, we are gonna mark this as zeros. Also because we are gonna do D1 via 1, we have to consider the 1 as middle vertex. So the row and this column from D0 corresponding to D1. So we are gonna draw as it is 0, 9, 4 and infinity, and the column 6 and then infinity. So we have these blanks to find out. So what we're going to do is we have to find the 2 to 3. So for that I'm going to use some kind of formula. Okay, so when we are going to find the 2 to 3, we have to follow some kind of a formula like this. So if you look carefully, this is the column that we already finding, and then right here the 2 is from right here and the 1 is from this one, because we are implementing this matrix via 1, via element 1. Therefore we are gonna then right here the 1 is come from this element, because we are implementing this matrix by via this 1, and then this 3 is come from right here. You have to look carefully to understand uh, how the formula works. So 2 to 3 is infinity, 2 to 1 is 6, and 1 to 3 is minus 4. So 6 plus minus 4 is 2, and the infinity is right here. So after we finishing these steps, we have to get the minimum number, which means the minimum distance. So you can see it's obvious the 2 is the minimum number. So therefore we are going to take 2 for this particular column. So this is the formula to find the distance 2 to 3. So likewise we are going to use the same formula for 2 to 4. Let's look at it. From D0 we have to look the D2 to 4, and then from D0 we have to look the 2 to 1, because we are implementing this matrix by 1, sorry, via 1. and then plus 1 to 4. So 2 to 4 is 2 to 4 is 2, 2 to 1 is 6, 1 to 4 is infinity. So 6 plus infinity is infinity, and then this 2 is right here, and it is obvious that this 2 is the minimum number, so we are going to use this 2 for here, and then we are going to do the same for 3 to 2. So from D0 we are going to find the 3 to 2, and then 3 to 1, and then 1 to 2. So 3 to 2 is 3 to 2 is 5. 3 to 1 is 3 to 1 is infinity, and 1 to 2 is 9. So it is, oh I'm sorry, there's plus right here, and infinity plus 9 is infinity, and this 5 right here, and the 5 is the shortest number, so we are going to add the 5 for right here, and then we are going to do the same thing for 3 to 4. 3 to 4 is infinity, and 3 to 1 is infinity, and then plus 1 to 4 is also infinity. Therefore both side contains infinity, we are gonna use the answer as infinity. So 4 to 2 is infinity, 4 to 1 is infinity, 1 to 2 is 9. So we are gonna mark it as infinity, and we got the last one, 4 to 3. 4 to 3 is 1. 4 to 1 is infinity. 1 to 3 is -4, and you can see the 1 is the shortest. So this is the D1. Okay, so right now we are gonna do the D2. So right here also the same thing that we do for the previous ones. So in here we consider the element 2 as the middle vertex, which means we are gonna create the D2 via 2, the element 2. So so in here also we consider D1 as our base matrix, so we are going to implement D2 from D1. So in here also the same thing, the diagonals are marked as zeros, and the corresponding rows and columns from D1 which is corresponding to the element 2, this one and this one, which means this and this. And we have to fill these blanks up. So the formula is D1, because we implement D2 from D1, therefore our base matrix is D1, so our formula is based from D1. So D1 our column 2 to 3, this one, sorry, 1 to 3, and then D1 1 to 2, and then also D1, sorry, 2 to 3. So the 1 to 3 would be -4, and 1 to 2 is 9, and the 2 to 3 is 2, so 11 minus 4. Obviously it is the -4, so the -4 goes right here, and then we got the 1 to 4. So 1 to 4 is infinity, and the 1 to 2 is 9, and then 2 to 4 is 2. So here also 11 and infinity, so the 11 would be the shortest, so 11 goes right here, and then the this one 3 to 1, sorry, 3 to 1, and then sorry, 3 to, so 3 to 1, so the 3 to 1 would be infinity, and 3 to 2 would be 5, and then 2 to 1 would be 6, so it is 11, and so the shortest one is the 11, so the 11 goes right here, and then the 3 to 4. 3 to 4 would be infinity, and 3 to 2 would be 5, and the 2 to 4 would be 2, so 7 to, so the 7 is the shortest, so the 7 goes right here, and the last one the 4 to 1, 4 to 1, then 4 to 2 plus 2 to 1, so the 4 to 1 would be infinity, 4 to 2 would be infinity, 2 to 1 would be 6, so 4 to 1 would be infinity, 4 to 2 would be infinity, 2 to 1 would be 6, so the answer is infinity, so the 4 to 3. Please don't mind, my drawing is very bad. So 4 to 3 would be 1, and the 4 to 2 would be infinity, and 2 to 3 would be 2. So 4 to 3 would be 1, 4 to 2 would be infinity, and 2 to 3 would be 2. So the 1 is the shortest. So 1 goes right. So this is the D2. Is also the same way that we do to the previous ones. So right here we consider 3 as our middle vertex. So the element 3 would be our middle vertex. So the D2 would be the base matrix. So so we are going to implement D3 via 3, the element 3. So first thing first, we do the rules as previous ones. The diagonal will be the first thing first, we have to apply the rules that we applied for the previous ones. The diagonal elements would be zeros. So, and so the corresponding row and column from the D2, we're gonna write it as it is. So the uh, this row and this column. So the column will be 5, 7, and then -4, 2, 1. Okay, so we have to fill these blanks. So for that, we're going to use the D2 for our formula. So from D2, so the first column would be 1 to 2. So 1 to 2, from D2, 1 to 3, sorry, plus D2, 3 to 2. So from here, 1 to 2 is 9, and 1 to 3 is -4, and 3 to 2 is 5. So 1 to 2 is 9, and 1 to 3 is -4, and 3 to 2 is 5. So this is going to be 1 and 9. So then 1 is the shortest. So the 1 goes right here. And 1 to 4. So 1 to 4 would be and 1 to 4 is 11, and 1 to 3 is -4, and 3 to 4 is 7. So it is going to be 3 and 11. So the 3 is going to be right here. So likewise, you have to do the other things as well. Applying same thing for the other columns. So the D4, it is also the same way that we done for our previous ones right here. So right here also we consider element 4 as our middle vertex, and the D3 as our base matrix, and we are going to implement D4 via element 4. So as the first rule, all the diagonal elements would be 0, and also the corresponding row and column right as it is. So 12, 6, 1, 12, 6, 1, 0, and the 3, 2, 7, 0. And for the 1 to 2, we're going to use the D3 for our formula. So we're going to find the 1 to 2. So, and D3 1 to 4 plus 4 to 2. So as you can see, 1 to 2 is 1, and 1 to 4 is 3, and 4 to 2 is 6. So 3 plus 6 would be 9, and then the 1 would be the shortest one. Therefore we're gonna write it down. So the next one, 4 to 3. So this one is 1 to 3. So 1, 4, and 4 to 3. So 1 to 3 would be minus 4, and 1 to 4 would be 3, and 4 to 3 would be 1. So 1 to 3 would be minus 4, 1 to 4 would be 3, 4 to 3 would be 1. So the minus 1 would be the shortest one. So as you can see, this would be the final result. So D4 shows the uh, shortest path for every node. So after you find all of these, the D4 become the final one. So this tells us the shortest path for all the nodes. So I think this video might help you a bit. So make sure to subscribe and hit the bell button. So catch you later.